start with the basic one. Let's import the file first. DataFrame, yes, this has been imported. Now, df.shape. So how many rows and columns it has? It has 8,399 rows and 18 columns. So 8,399, that's pretty huge. Now, if let's say I have to, based on this existing data, if someone asks me, like, so which particular order or which particular ship mode gives you more profit? Let's say that is a question. Now, right now, I can do it. Right now, I would be able to perform this because this number is finite. I know 8,300, I can do it. But what if the number is 83 million, 83 crore, 8,300 crore, or something even bigger, or something which is on real time, right? Something which comes on a real time. So I don't know the number of rows, or I don't have that much of computer resource to perform this operation, or GPUs or CPUs. I don't have all these high-end stuffs. Then I will take the help of statistics. What I will do from this entire gigantic, population, I will take a small sample of this ship mode. I will take a small sample. Now, when I will do it, like even here, there is an option of sample, data frame sample, and then within that, you have to just mention the number of samples you want. That's it. So this is the same thing that it's doing. Just come here, have a look, returns a random sample of items from the axis of object. You can also use random state for reproducibility. That means every time I run this code, the values will change. If I run this now, I'm going to get new set of values, right? So if I want the number of values to be constant, so I have to keep a seed which is known as random state. If I keep the number same, every time I'm going to get the same number of rows. Okay, that is fine. But the point here is that from this entire population, I'm able to fetch some random samples. Now, why random? Random means every chance of getting selected by every row is equal. There is no bias in the data. So in a real world, how can we say it? So random state or randomness is, let's say if I am selecting a particular cricketer from a Indian state, if I select it randomly, then any cricketer from any state will get selected, will have an equal chance of getting selected. But if I have bias in the data, probably I will take someone only from, Tamil Nadu or only from Maharashtra. So that means I have bias in the data. That means if I have 10 rows or 10 cricketers, probably 8 of them are from Maharashtra, or let's say 6 from Maharashtra, 5 from Tamil Nadu, and 1 or 2 from any of the other states. Now, if I take this random, if I, sample this data, I will get high numbers from, from the states which represent majorly, right? Because that is not equally distributed. Because that data is not equally distributed. Okay, we are talking about ship mode. Let's quickly check how much has been the distribution of ship mode. This will give you a good perspective of how things are. Dot, how do we do it for categorical? We do it using value counts. Oh, ship mode. Ship mode. So this is the ship mode, right? So what it says, the regular air is 62. Let's convert this into percentage. Now you can either do it this way, like, so this gives you the total number. So you can just put divided by length of DF. Length of DF will just divide this number by total. What's wrong with me? Yeah, length of DF. So this gives the same thing, or there is a shortcut way, which is just put normalize here. Normalize is equal to true. This will do the same thing as well. So I can see 75% comes from regular air. only 13% from delivery and express here only 11% or 12%. So I can say, so if these all are classes, this is class 1, class 2, and class 3, I can say the distribution is not equal. The distribution would have been equal if the number of distributions were like 35%, 35%, 35%. Then it would have been equal. But right now, I can clearly see the regular air has a bias in that. That means it's is there in more number of times this regular air has happened. So if I select, now understand one thing. So until here, we were just talking about randomly. So this is selecting anything randomly. Randomly means everything will have an equal chance of selection. Now, if I do the same random selection here, do you think, let's say, if I select some random data from this column, how many do you think will come from regular, delivery, and express? More from regular, right? Because that number is more. So of course, more number of observe. Let's say if I random select this ship mode for probably 20 rows out of this 8,000. So out of those 20, 75% will come from regular. That means 15 or something, 15 rows will be of regular only. So that is bringing a bit of a bias element into it. Bias means tending towards one direction, not uniform or not normal. Bias means something which is tending towards the left hand side or the right hand side. It's not like strict and it's not very much, let's say, honest or something. So that is something which is bias. Now, so this is an issue with it. We can clearly say this is an issue, but this is a real world scenario. So you cannot say real world data has some issue with it because that's how the business works. So there cannot be an issue with the input data. So we have to tackle it on our own. Instead of, so in that case, what we will do, instead of random selection, we will do a stratified random selection. We will do a stratified random selection. Let me quickly see if, one second. Selection. Random selection. Let's see if we are getting something really good or not. So that is the point. So what we have to do, how do we tackle this data? We have to use a stratified random selection, which will ensure the number of, the percentage of, regular air, delivery air, and express. If I take that into a proportion, right, if I take that into a proportion, it will be 7:1:1 or something like that. So that will remain intact so as to avoid the bias in the data. That is known as stratified random selection. So basically, these are different types of data selection to create the small subset for your further, statistical analysis. So from your main population, you have to select a small sample, a small subset. Now to select that small subset, how are we going to do it? Number one, either we go for a random selection like we did here, just df.sample 25. So this will randomly selected 25 rows out of 8,300, these many things. Randomly selected, but also we have to check if for specific concern, if there is anything that we should look into, if there is anything that, we can work on. So then we have to bring in that, aspect also into the minds. Like if it needs to be, I'm trying to get this. Sure. If there is a good, yeah, so this is simple random sampling. I think this is good. Yeah, this is better, I think. So yeah. So randomly sampling, so this part is needed for the sample creation, right? So these, understand these two are the most important that we will use. So the first is simple random sampling, which I said. So simple random sampling is sampling like every individual items will have an equal chance of getting selected. So if I do a simple random sampling of 4, these 4 person are getting selected. Next time, if I do this operation again, maybe some other 4 person will, get a high chance of getting selected. So that technique is known as simple random sampling. But what if my data is in this type of format? Like, can you see here, there are 3 person who are darker and there are 5 person who are little, gray shaded. Hello? Hello, can you see it?
Yeah.
Yeah.
Okay, so the point I'm trying to make is, so stratified, so simple is like, let's say if I am selecting 100 cricketers from entire India, so every time, every single chance will have a high chance of getting selected, equal chance of getting selected, not high or low, equal chance. But what if, let's say, my input data has something like only states, from Maharashtra and Tamil Nadu and rest of India. In that case, my simple random will not make sense, right? Because simple random might select all the players from Maharashtra, might select all the player from Tamil Nadu. In that case, I have to keep that in mind that so as the most number of players are from a particular belonging, I have to give that preference also. I should not select everything from that particular segment. Is that, if that is clear? Otherwise, I'll quickly jump into Excel to just right. Let's say this is Mumbai. 1, 2, 3. And this is Kerala, say 1, 3, 6. So let's say we don't, let's hide it. Let's say these are the number of players we have. Count is 13. We have to select 6 out of it. We have to select 6 out of this 13. We can do it, right? So if we do a simple random sampling, that means all of them will get an equal chance of getting selected. How? In that case, there is a percentage of selection. So what is the percentage that this player will get selected? So this will be like, so the count here is 1 divided by how many total number of players we have? 13. So 1 divided by 13. So why it's like number complicated? Yeah, like that. So like this. So G divided by, so if I drag till here, these two, there's nothing, just drop them, there's nothing. Yeah, you know what happens. So yeah, just to make it consistent and keep it simple. So these are players. Now, what if I go with simple random sampling? This will be based on this percentage, or we can say the probability of this individual, this number is getting selected is 1 divided by total. That is the probability of getting selected by this item. Is it making sense, or is it not making sense at all?
No, everything is 1, no? So all numbers are divided by 1, you are saying, huh?
Don't consider them as one. Just think, this is like one player is getting selected. Don't focus on number 1 or 2 or 5 divided by, not that thing. What I'm trying to say is only one is getting selected. If this is one player, these are one individual players.
From
So
one different states.
right now, just ignore the states. Right now, just say these are the list of players. One
Okay.
player. Then what is the probability that this one player will get selected? The probability will be, probability is equal to that particular player or that particular instance divided by total player or total instance. Right? So that particular divided by total. Now for this case, what is happened? So that particular instance, which is 1 divided by total number of instances, 13. So 1 divided, I don't know where this date is coming, but it's something like 0.076 or something. So 7.6%. If I convert that into number, it will be 7% or something. So this is random sampling because I don't have any limitation of barrier between them. So if I apply this mechanism, if I apply 6 out of it, so any of the 6 numbers can get selected because they are random sample, the number is same. There is no number higher, no number lower than anybody, right? So any 6 number will get selected. So if I run this simple random next time, another 6 will get selected. If I run this again, another 6 will get selected. Now, that is the first point. Now, why I wanted to hide is, let's say this is the case. These 6 are from a particular area, these are from a particular, and these are from a particular. Now, I have no control of, this on the column each, I don't have a control on which state they are coming from. They all are getting treated equally. They all are getting treated equally. So if I do a simple random, it's selecting randomly. So there's a high chance that it selects all 6 from this state itself, right? Or it selects all 4 from this and all 2 from this. Then this will not even get selected. Or probably all 3 from this and all 3 from this. Then it will not get selected, right? So that's when this stratified random sampling came into the picture. Stratified random sampling came into the picture. Let's say I need only 6, but but what this stratified random sampling is doing, so strata means classes or individual segments or individual zones, like we all probably belong from a town, so that town will be a particular strata if I take the entire India, or let's say Indian states. So if we look from outside, now one Indian and another Indian will not look similar because
Correct.
of the strata difference between them. Strata in terms of society, in terms of finance, in terms of culture, in terms of language speaking. So all these are
Correct.
stratas.
Okay.
Similarly, if we come here, we can see that there is a difference here. So if I simply go for simple random sampling and based on this equal number, everyone will have an equal chance of getting selected. No, I should somehow change this so that the numbers are somehow managed in a certain way that it's probably changed in a certain way. Instead, what will I do? I will divide them by individual rows. So what will I do? I will divide them by 6 instead of 13. Similarly, if I go here, I will simply divide them by 3. And if I go here, I will divide them by 4. Now see, the probability of getting selected number has changed. Right? So the more the number it is, the more chance of this gets selected. Now, these players are less in number. So if I randomly select them based on strata, there's a high chance that one will get selected from here. That is for sure. If we take one player from this, there's a high chance, 25% chance that one player will definitely come from here. And there's a 16% chance that one player will definitely come from here. So as to accommodate the final, if I select 6 such players, the final number should be equal to, 100 or something like that. I'm just giving an example. But that is how usually we tackle this situation of whenever there are multiple classes involved. So now coming back to the main issue that we had here, sheep mode. So we clearly saw sheep mode has 3. One has 75%, one has 13%, one has 11%. Similarly like this. So let's say Tamil Nadu, which has like 16%, MU, which is occupied by 33%, and KE by okay, if we divide it by, let's say these are how many of them? 6. So is equal to 6 by 13. 6 by 13, and then this, and then this. So what these are? This will be 3 by 13, and this will be 4 by 13. This will be 4 by 13. So what this column is? This column is the percentage of their contribution to the entire data set. So this column, column I, this is this particular column. Just try to, try to match between these two things. Are you able to do it? So ship mode also has 3 classes. 75% of the rows belongs to regular class. Similarly, if I look here, I can say 45%, 46% belongs to this particular class. 23% belongs to this, 30% belongs to this. So the question that we had here, if I do a random selected, there's a high chance that a lot of rows will come from here. Similarly, like this, if I do a random selection, there's a high chance a lot of player will come from this, a lot of rows will come from this, which I don't want. I want this percentage to remain intact. So if I'm selecting randomly also, if I'm selecting randomly also, this percentage should be intact. It should not be I'm getting more number from here or less number from here. So that is why we have to keep the stratas in mind. We have to keep the stratas in mind, the individual strata, and then we will just do the percentage in a different way. And based on the weight, I will be taking players or I will be taking rows. If the rate is high, I will take them from, more from there. If the percentage is low, I will probably take less data from here, and so on and so forth. So that is how usually these are the 2 types of things. One is simple random sampling, one is stratified random sampling. Now let's come here. Okay, real world example of a simple random sampling. At a birthday party, teams for a game are chosen by putting everyone's name into a jar and then choosing the names at random for each team. Right? Let's say for a birthday party, there have been 3 or 4 teams been made and their names are put into a jar, and then we select them randomly. So any of the 4 names can come, right? There is no bias into it, like only a particular team will come or something like that. It's a randomly, it could be anything. So randomly, what is the chance of everyone? 1 divided by 4, that is 24% chance of everybody to be selected. So that is on the random sampling. Stratified is entirely based on groups, and it talks about the same thing. Okay, there is one more thing. Do they have image? Cluster is something that we don't, we will be using it later. So see here, cluster is similar to stratified in that both begin by dividing into groups based on a particular characteristics. So here our characteristics, which state they are from. Similarly, in the data set that we had, what is the characteristic? The type of modes that they operate in. One is regular air, delivery truck, and express air. So that is the type of mode that they operate. So that's the particular characteristic based on which the stratas have been divided. But while a stratified survey takes 1 or more samples from each cluster, chooses clusters at random, then samples from them. Okay, so what this does is essentially instead of selecting individuals, so first it will select an entire cluster. It will select an entire strata, and then it will do a random selection from that. So, right, it's practically, we don't use this on, regular basis. These are the 2, just keep in mind, these are the 2 that we would be using every now and then. Simple random sampling and stratified random sampling. And this is the basic background architecture of how it works. Now, in Python, it's just 1 line of code, right? It's just DataFrame.select.sample. That's it. It's just 1 line of code and it's working. If we go a level deeper, then there are other things that we will cover later. where you can play around with the stratification, you can play around with how much percentage of data you want and all of that things. But roughly this is it. So here we have seen how to select data, how to select data. So data selection is something that we understood, right? That is something that we understood. Now, in statistics, there are two very important things is first, taking a small subset of data and then understanding the data, like what exactly I should do, or basically proposing your hypothesis. So if I take this one, if I this df dot head. So if I take this particular data set, this is about customer sales and all of that stuff. Now, if I have to, now this is based on this data, whatever results I will deduce, that will be the null hypothesis, because that is something that has already been defined. Like if I just put, let's say, the profit here, profit dot mean, if I say it like this, I'm getting the profit as $181. So this is my null hypothesis, because null hypothesis is something that is already been explained and that has or a generally accepted terms. So this is something that is obvious, that we know there is no way this can be different if you do any other mean in any other way. So if you do mathematics, if you take average, the average of profit will be 181. As simple as that. Similarly, the sun rises in the east and sets in the west. That is something that we have heard, right? So that is my null hypothesis. Then again, we get up early in the morning, we go to sleep early, something like that. So that is also a null hypothesis. So these are null hypotheses which are meant to, so these are null hypotheses which are a generally accepted term. In case you differ, you contradict with that null hypothesis, then you will come with your alternate hypothesis and then you will submit your research paper. Then you will come with your own findings. You following me? Let me give you an example. Let's say this is the superstore data set, and this is something which comes on every month. And we know that the average value is around $180 or something like that. Is around, sometimes it's 181, next month it's 182, next month it's 179, something like that. It's around that particular range. Now, let's say you are working in that store or something, and you are seeing that the profit is much less or much higher than this. In that case, what will you do? You will come with your, so what is the null hypothesis here? The null hypothesis says average monthly profit is, let's say, $180 or 180 rupees or something like that. USD, $180. That is your null. Now, based on your observation, let's say Ranjit and Sian, you two are working on a team and you have been collecting data and doing investigation and all of that. You are seeing that that's not really the case. So you guys will propose your alternate hypothesis that the average monthly profit is not 180 USD, which also means either the profit could be higher than 180, or sometimes the profit could be lower than 180, but it's certainly not 180. So that will be your alternate hypothesis. Are we clear until this part? Then I will proceed with some other things. For any doubt, just let me know. Ranjit, Sian?
Yeah, understood.
Yeah.
Good.
Okay.
Okay. So the basic thing is, so this is your null hypothesis. which is something which is already accepted. Alternate is something that you will come up with. So mathematically, if I have to write it, how will I write it? So your null hypothesis is something that we usually denote as H0. H0 will say average profit, which takes in the shape of mu. But yeah, let's write it like this. Average profit is equal to 180. However, your alternate hypothesis HA says the mu value is not equal to. So there is no means to write it on the screen, but so not, or let's write it like this, not equal to 180, not equal to 180. So that will be your alternate hypothesis. As simple as that. So now, how are you deducing to this fact? So that we will see. How are you coming to this conclusion that your alternate, you are saying that you are not agreeing to the fact and you are coming up with your own set of analysis. That we will see here. But how to identify what is a null hypothesis? Null hypothesis will always have an equal to sign in the equation. Like the sun rises in the east, right? We know that. So sun rises equal to east, or we can say something like, the what could be your null hypothesis else? The ideal, let's say the ideal hemoglobin level of human body is greater than equal to 10 or something. So that is your null hypothesis. Now your alternate could be no, I beg to differ, and you always contradict that statement with a different equation. So if the null says is equal to 182, so your alternate will be not equal to 180, which means mu could be either greater than 180 or mu could be either less than 180. So that is one thing. Let's say the null equation says greater than or equal to 180, like the profit that they are claiming is greater than or equal to 180. So then you will have only one option. Mu will be less than 180 and something like that. So the long story short is the equation should match every time. The equation cannot be different. Like the null says mu greater than is equal to 180 and you are saying the average is greater than 200. It does not make sense, right? Because greater than 200 is equal to greater than 180. They both are in the same thing. So it has to be something different. Then only you can propose a new alternate hypothesis. So that is all about null and alternate hypothesis. Now, something which is already accepted, something which is not already accepted. Like, one example could be, you're working on a chocolate factory and you are making, that dairy milk, they makes these chocolates, right? So the average weight that is being produced in the factory is 5 grams. So that is what Cadbury or Dairy Milk claims. But let's say you have bought, hundreds of dairy milks from every part of India, and then you have done your calculation and you have seen, no, it's wrong. The claim that they are making, it's wrong. It's not equal to 5. However, it's not equal to 5. Like sometimes it's more than 5 or less than. Now, more than will not be there into the picture, but usually it will be less than 5. For most of the cases, you will see that the size of the bar are less than 5. So that could be one of the case, and then you can probably go legally and fight it or something like that. So that is one thing of null hypothesis and alternate hypothesis. So for that, we need certain things in place to be able to do all those calculations. The first thing is mean, which is average. So average value is something that you have to calculate, right? That is the first thing. You need to have an average things in place. We should be able to do the calculation. That is the first thing in place. And then you have to look for the data distribution of that particular term. Now, if let's say we are talking about profit distribution. Distribution means how the data is spread out. That is all about distribution. How the data is spread out. So, import C born as SNS. So this is one particular graph, one particular module for images or visuals. SNS dot hist plot. So this will plot a histogram. I'll show you what a histogram is of it. Because the data has been spread out on huge number of things, the graph looks pretty small. If I make it a little bigger, more bigger. So so the first thing quickly understand a histogram is, so this is something which we call a histogram. Histogram is something which will try to see the distribution of the data. Okay, let's quickly understand what a distribution is. Statistics distribution. It's pretty easy. It's just plotting your data together. It's just plotting your data together and seeing how that data looks like on a distribution graph, on a graph, as simple as that. Let's say, let's take one simple. Things like coming. Yeah, just focus on this one, normal distribution. One second, hold on. Yeah, this one is better. This one is better. So here, how many? 1, 2, 3, 4. So there are 4 charts here. So what these are essentially 4 sets of data which are put together in a graph to see how the data point lies on the graph. Right now, there are statistical process to identify that. We will not go details onto how to plot them, but Python is giving me flexibility to use something called hist plot. Hist plot, if your data is numerical in nature, right? Like the profit is a numerical number, it's a floating point. So if your data is numerical in nature, then you can use this hist plot. It will just show you how the distribution of the data values are. Now, here, let's focus on the blue one. So can you see it's nicely and normally distributed bell-shaped curve?
Yeah.
Nicely distributed. There is no tweak, there is no skewness, there is no twist and turns on anywhere. The blue one specifically. It
Yes.
comes and exactly at 0, it takes a nice jump at the top, and again it comes down, and it's very nicely represented even on both the sides. So the jump starts from -1, the jump dips at +1. So it's, so these type of graphs or this type of data distribution are known as normal distribution, which are equally distributed on, the zero axis. Zero axis is your mean, basically the average. That means if, now how do we plot a graph? Okay, so how do we plot a graph? So graph is plotted based on data points. So if we have 1,000 such data points, let me create something here randomly, is equal to random is equal to random between 10 and 99. This will give me some right profit, and if insert scatter plot this. So these are the data points, right? These are the different data points that we have here. But imagine if these data points were something like, it starts from a lower value, then eventually goes till 0 and then comes at something like this. So let's say it starts from -3, then -2, then -1, then at 0, 0, not like this 0, and then 1, 2, 3, something like this. So now this is actually a bit different because of the layout and all of that. But the point I'm trying to make is that if I take this data in such a way that it clearly tells you that where exactly the data is majorly located, on which particular data point the data is majorly located. So that can be observed from a distribution, probability distribution. Like what is the probability that this value comes in this range? Now 0 is the average. That means if we look at the blue color graph, then we can see most of the data points are in that average value region. Let's say the average is 15, then most of them are lying in that average value region. You guys are following me? So most of the data points will lie in that blue color region. So that is known as that is a normally distributed graph. And then it will be nicely, less values are on the extreme ends. But mostly things will be on the around the mean or around the average. So if we say something like this, or what was the value? Let's say this. Now, what is the mean? What is the average of all these numbers? 55. Let's keep it here. 55. Now, how much this minus this? So if we put all this into a graph, then it might take the shape of this. So here, this will tell me how much each data point is deviating from the mean. So for the first one, it will say it's 7 point deviating from the mean. So this is my mean average. So it's 7 point different from the mean. Second one, it's 19.75. It's very different. This is even further. This is also very different. So here, instead of staying close, all the points are very different from the mean value because of their difference, right? So if I put something like this on a graph, I might get the shape of a red color, not the blue color. The blue color tells me all the values are lying within the mean region. But that is not the case with me. For me, the case is probably the yellow one or the red one. Mostly the yellow one for me, the case will be. Because none of the value are very close to the mean. All the values are, they do have a good number of difference with respect to the mean values. So if I have to put a histogram out of it or a probability distribution, I might get the shape of a yellow color one. So basically this will help me to tell how much they are closer to the mean and how much they are different from the mean, right? Now, how this will help me? Okay, quickly I will tell you what about the yellow one then? Sorry, the green one. Can anyone tell me what the green one then? Hello, just say something. Ranjit Sian, are you guys there or I'm the only one talking or is it? No, the participants all see. So can you just get something like what the green one is? So the green one means these are on the left hand side, right? So that means the this major chunk of data, they have their difference in negative with respect to the mean, with respect to the average. So if in my data, if we take all the negatives, where the difference with respect to average is negative. So these are the negative values, right? That is what this graph talks about. So as our case will be mostly with the yellow one, but if we had more number of negatives here, like say 60, 70, 80% of them are negative, then our graph would have taken the shape of this green color one, where we are very differ from the average value. So that is what a distribution is all about. That is what, so what we understood here is if my data is normally distributed like blue, then nothing like it. If it is normally distributed like, the blue color or red color, or in fact this yellow color, but something which is green color, that means there is something wrong with it. We have to rework on it and make it usable. Otherwise, the hypothesis that we are going to predict or the statistical test that we are going to conduct will not make any sense. First, we have to make the data, appropriate, and then we can go on with doing any search types of test or something like that. That is the same thing here. So here, what we can see is most of the data. So the most of the data most of my data elements of profit are in that particular zone, in the zero, in the average area. However, in that graph, we are not able to see, but there are few elements which lies towards 20,000 as well. And there are few elements which lies towards minus 10,000 as well. So it's not very center. Here we are seeing yellow is, the blue one is pretty much in the center, which is a good thing. But here it's more twisted towards the other side. It's more twisted towards the left hand side than the right hand side. That means, sorry, it's more twisted towards the right hand side. So I have more number of positive. That means the overall profit has happened in a positive way. Otherwise, I would have more numbers of negatives here. But this has taken the shape of this U, inverted U, and then it has go on and on and on and on and on. Because there are a lot of smaller values between the positive range, probably between 0 to 10,000, 10,000 to 20,000, and even more. So that is the data distribution that I have. Right. So that is the data distribution that I have. Now I have to, so the ones that data distribution is normally distributed, that means the data are pretty much in a good format and they are getting captured into the system with, good number of elements. So if that thing is fine, then that means we can apply any statistics on this data to get whatever I'm looking forward to. Whatever I'm looking forward to. One more important thing will be your that I have to show here, but I have to show you how this is calculated, right? So let me just show you standard deviation calculation. So for statistics, another important thing is your standard deviation. So standard deviation means it measures the spread of data distribution. That means whatever we have been seeing here now, how much the data is spread. Now, this is not really good graph. But if I look here, so standard deviation means how much the data has been deviated from the mean value. So the mean value we know is 181. That is the mean value. So how much of an actual value is deviated from the mean? Now here the is minus 213. Here it's how much? It's 457.81. This is 46.71. So how much they are deviating from the mean? So that is something we have to calculate in the form of a standard deviation. So let's do that first. So the standard deviation. So let me quickly take X mean. So the first thing is I have to calculate the mean value. Now mean is the average, which will remain essentially will remain same for all the values, right? It will not matter. It will not differ. So mean. So let me just drag this out. Let me just keep it fixed so the value will not change. Yeah. So this is the mean 55 out of all profits. And here, what is the thing I need to do? I need to do some calculations, which is mean minus the actual one. Mean minus actual. So how much the overall value are different, are, getting apart from the mean. But the problem here is I'm getting a lot of negatives also on top of positives. So the best way would be to just multiply it out to get rid of the negative value. Now this is what I'm getting. So then what essentially does is sum of this by this. That's it. So what essentially is doing just a sum of, so standard deviation would be sum of all the values divided by count of all the values. Count is basically just how many, values that we have here. So this is 63 and this whole has to be within a square root. So I'm getting 25 point something. Now, if we use a standard function, how much are we getting from Excel? Yes. So we are close. So 25.7 is what Excel tells me. 25.1 is what I am getting on my own. So we are good. So 25 is the standard deviation. So 25 is the standard deviation from the mean. So these are all the data elements. These are all the individual data elements. And for this entire data element, my standard deviation is 25. That means for 25 times they are spread over the mean. So if I take all these values and put them into a, a normal distribution of, like 0 and, either negative and positive sides, I can see up to 25 will be the spread on either side that the mean will go. So that is what the standard deviation is all about. So if you look at even the definition, standard deviation measures the spread of a data distribution. It measures the typical distance between each data point and the mean. So from mean, we have seen 55. So from mean, how much has been the actual value has moved. So standard deviation is something which calculates that. So standard deviation is something which takes care of that part, like how much it is deviating from the mean value. Now, if I have to put the same into a normally distribution graph, the things that we have been seeing until now. So normal distribution, it has a formula. Let's try it out if this works or not. So X is the actual value, mean is the average value, then there is a standard deviation, and then there is a cumulative, which is, I think, true or false or something. How do we? Right. Let's drag it. So now this is my normality distribution. Now, if I put this, try to put it, will it take? This is the normality distribution. It's not taking because I think I have to sort this out. Now see, this is coming. So this is what I've been trying to say. Now, these are all individual data elements, and this is their normality value. Normality means what is the probability that this will be closer to the mean, or this will have a standard deviation of this. What is the probability on that? Hold on, the standard deviation should be same, right? Right. Yeah, this will be the. Now, can you see if this value is closer to the this thing? It's getting closer, right? Anyway, leave it. So this is how the distribution of the data will look like. Now, right now, it slightly takes the shape of a normal distribution, but it's not very much in normal because I don't have a negative value. It's all in positive. So because the data is not, so these are all randomly selected numbers. These are not real time or, real practical business numbers. So these are something that I've created normally. But the point I'm trying to say is Standard deviation, understand these 2-3 things. Standard deviation mean how to calculate the average. These are the formulas to calculate standard deviation, not at all needed, because in Python, in any other programming language, you will just write one single line and you will get the output. So you need to calculate standard deviation, that how much it is spread or deviated from the mean. And next you have to calculate the normality. The normal, if at all the distribution is normal in shape or not. So that is how you plot the distribution of any data into it. Now, if we come back here, this is the same thing that we have been trying to do. So this is in hist plot. And here in Excel, we have done so many things to calculate to reach to the same conclusion. But in Python, that's why Python as in machine learning is such a boom, and it's so much of, in demand in the market. It just calculates the data distribution, and with just one or two, just with these 4 lines of codes, it just gives you the entire data distribution, with the standard deviation extent and all of that. So that is the first thing that we should do for any type of data statistics or data analysis, that if my data is normally distributed or not. If not, there are multiple ways to tackle that. There are certain transformations. Now, what if data is not normally distributed? Then there are multiple ways. There is a log transform, there is power transform, and there are a lot of other things that you can keep on exploring based on what is your need. But long story short, this is the first thing that we should do. Now, coming back to the the statistics that we did, we were after proving we were after coming up with our own alternate hypothesis that the average profit is not 180 if it's either more than 180 or less than 180. For that, we had to collect our own profits. Let's say this is the new set of profit data that we have collected, right? In that case, that is the first thing that has been a good thing for us, which is normally distributed. The data has been normally distributed, which is a good thing for us. Okay. What next? Next is we have to come up with a test. Next is we have to come up with a test. Based on that test, we will do our whatever needed to do. Now, what the tests are? Tests are usually of 2 types. One is z-test or a t-test. Now, how to do when? Now, if my sample size is greater than 30 and the population standard deviation is known, or given to me, then I will go for z-test, else t-test. Are we clear on this part? When to do what type of test? So first we selected data. First we we created a hypothesis. Once a hypothesis is established, then we have to derive the data. Ideally, the data is the first thing that we should derive. Then based on that data, we take a call of whether it aligns with the normal null hypothesis or we are getting different result. Like, if this is the Cadbury, this thing, then null has already been marketed by Cadbury company that the average size is 5 gram. But once you carry it on your own, that means you collect the sample on your own, you by going to every other district, every other state, and you collect the Cadbury, you take a weight, and you are seeing sometimes it is less than 5 grams, sometimes it is more than 5 grams. That is when, once your data you have, which is normally distributed, all these tests are done, then you are coming up with this conclusion that this is completely a wrong statement. However, the real is different, and this is my alternate statement. Now, if there are somebody else researcher in the market, just come out and prove me wrong or something like that. So that is how it goes. So data distribution part is done. That is something we have seen. Data selection is something we have seen using random selection, stratified sample. Next comes two important things. Now, in a practical real world, these are getting used in very minimal, because nowadays a very less section of people are doing hypothesis. I mean, they are actually working on hypothesis. Most of the people are working on, on machine building or machine learning or this kind of stuff. So I will not take much time here because it's just good to know things. So Z,
Nothing, sir.
okay. So what is this? So there is a Z test, there is a T test. So what it does is, so again, I don't have any document with me. So let me quickly show it here. A Z test is used in hypothesis testing to evaluate whether a finding or association is statistically significant or not. There are a lot of terms here. Let's break down one by one. Z-test is used in hypothesis testing. Correct. We have seen that, right? Because this is the test that we have to do based on our hypothesis. Though it's alternate hypothesis we are trying to prove, but it's anyway part of the hypothesis only. Hypothesis means any standard algorithm, any standard process, that is an hypothesis. So is used in hypothesis testing to evaluate, means to calculate whether a finding or association. Finding or association means the result that you are doing, your alternate hypothesis, this part. The profit is less than 180 or more than 180. That is your finding or that is your association, right? Is statistically significant or not. Now, how to conclude if something is statistically significant or not? So that we can conclude based on confidence level. That is something that we talked briefly last day. If you guys remember, let me just open it quickly. We roughly taught about these things, right? Confidence level. That means this is all statistics, right? Like this is not real. This is all statistically happening. Nothing to do something on real. Like you are, okay, let me help you understand. Now, your null alternate hypothesis that you're proposing that, the average monthly profit is not $180. Or let's compare it with the Cadbury example. You are saying the average, Cadbury product size is not 5 gram. It is less than 5 gram or more than 5 gram. So this is an alternate hypothesis that you will propose, and based on your findings, people will either accept it or reject it. Let's say it gets accepted. Now, this is statistics. Now, let's say 1 year from now, Cadbury manufacturing company produces a Cadbury which is more than 5 gram, 5.1 gram. In that case, your this thing, no, sorry, it produces a Cadbury which is exactly 5 gram, 5.00 gram. In that case, your alternate hypothesis will fail. Why? Because your alternate hypothesis was based on some data, but you don't have access to the future data. We don't have access to future data, right? We do not know if something will happen in near future. So we have to proceed with certain level of confidence. If I ask you which team will win, you will say that I'm certain that India will win. But how much certain you are? If I ask you, you will say, I cannot be 100% sure, but I'm 90% sure because, the batsmen did well, the bowlers are playing good and all of that. These are the things that you will do, right?
Yeah.
So you cannot be 100% sure on statistics, on anything, on any prediction. You are 90 to 99% sure, but there is a 100%, there's a 1% error point that always you have to keep in mind. So that part is known as your confidence level and significance level. So confidence is you are 90, 95 or 99% sure that every time Cadbury creates a product, it will be either less than 5 gram or more than 5 gram. But there could be 1% chance also, right? That Cadbury produces a Cadbury chocolate which is exactly 5 gram. So it falls in that 1% error mark. So always for our statistics, for our hypothesis, for our any sort of analysis, we have to keep that in mind. That 5.6 feet is something that the example that we showed of average Indian male height is the it's my finding. But
Plus
I
or
say, yeah,
yeah, we have shown the plus or minus also. It's an average.
exactly. So that is the percentage of error that we have,
Yes.
right? So
Yeah.
similarly, for alternate hypothesis, so once I come up with my Z test, I will take a call, that is fine, but based on certain conditions. So this is the condition. This is whether they are statistically significant or not. Now, statistically significance call will be taken based on the percentage of error or percentage of confidence.
Will be under alternate hypothesis.
Sorry, come again.
So the statistical significant will be always in alternate hypothesis, no?
Yes, yes, because null is already established one. We are not doing anything on null.
Okay.
We are coming up with our own.
Okay.
Right, like if tomorrow I say you the average Indian height is 5.6 feet, that is your null hypothesis. But because that is something that is known, that is something that is known, right? Or let's say, let's take one more example. Let's say the skin color of somebody living in United Kingdom is white. That is a null hypothesis that we all know, right?
Yes,
But
yes.
is that always the case? No. There could be some people from Africa, there could be some people from India, from any other states where the skin color might be little gray or dark or brown or black or something else. So
True.
you will come up with your alternate hypothesis, right? Like
Yes.
like the null is not always right. I have done survey on my analysis. I am 95% confident and 5% error I have considered that there is this much percentage, then you will come up with your whatever findings that, so that will be your finding. And you will be 95% sure with 5% error into it, or 99% sure, 1% error into it. That's it. So that will be your reverse alternate hypothesis. Right now, that is why we need a Z test. Now, Z test can be done with, this is the two conditions that I wrote. Z test can only be done if the number of sample size is more than 30. That means more than 30 records you have. And the population standard deviation. Here, if we consider this as the sample, this will be my sample standard deviation. Or if I consider this as my population, this will be my population standard deviation. Just that in standard and population, there is a small mathematical difference. But that's something else. So if you have been given a task to work on this, and if the population standard deviation is given to you, like let's say somebody tells you the population standard deviation is 3, that means you have to do a Z test. So that is something you have to understand on your own. And let's say the sample size that you have been given is 1000 and the population standard deviation is 3. That means you have to do a Z test. Now, how to do a Z test, that is something else we will see. But that is the first thing you have to take a call, whether you should do a Z test or a T test for your data distribution or your further, findings. So let's see here. That is the first thing that you should do. Okay, tomorrow we will touch base on this one. This is really very important, but not right now. Quickly see here. This is something else that we will see. Or let's do one thing. Let's continue that tomorrow because I have to, I think, cover this one first. This one, central limit theorem. This is a very important and interesting thing.
Okay.
Central limit theorem, right? So once this central limit theorem is an already established fact in statistics, once that part is established, then we can go for it. Now, so ideally what is happening? So this is something that we have seen, right? Let's say this profit example, this profit example that we were taking, 180 or not. So what we will do ideally, how exactly we will do a z-test? So think logically. So you will have to take data on multiple steps, right? On multiple sample. If you take data on one sample, so even if you take stratified random sampling, that will not be a right mode of selection. So in statistics, if you're doing any sampling operation for hypothesis or null testing, you have to take multiple samples of data, multiple instances of data, multiple types of samples that you have to consider. So even for calculating this $180, $180 profit, the monthly profit, you have to take data for, let's say, 3-4 months or even more number of, let's say, 100 months of data or 100 different types of data you have considered. Like some data you have considered, let's say, which are for every first day of the week, like that. Then you have considered data which are for every 14 days, first day of 14 days, something like that. So using multiple combinations, you have considered multiple types of samples in your data. Now, understand, logically here. So this is S1, this is sample 1. Similarly, you have an S2, you have an S2, you have an S3, and you have a lot of things other. So the objective here is of z-test is that your z-test we are doing to statistically, check if the means are matching or means are deviating. If the means are matching and the means are deviating, that is the only thing that we are doing. S1's mean is how much? Let's say 178, yeah. S2's mean is 184. This mean is how much? Let's say 181, something like that. So I will be having lot of samples and I have to calculate the means of all, and finally I will be calculating the average mean of all. Let's say the average mean from all the samples I'm getting as 182. So that will be the mean of the actual data that I've considered. And that, how can I tell that for sure? That is what central limit theorem is telling me to do. That is what central limit theorem is telling me, that this is how it works. And so what z-test is doing exactly, z-test is taking two groups under consideration and it's just checking if statistically their mean is same or not. Then again it's taking two groups and then it's taking statistically their means are same or not. And similarly it keeps on going for all the different samples that we have. Let's say we had 100 samples. So for 100 times z-test is supposed to do all of that. And based on how similar or different they are, it will take a call at the very end that this is the mean, and there is something called a z-score. Z-score is essentially where exactly it fits on a, so there are some thumb rule. There is a chart which talks about a probability. So tomorrow we'll go into details of all of it. So that based on that value, what is the z-score I'm getting? Z-score is, suppose I'm getting something like that. And final thing is I have to calculate a p-value out of it. P is the final probability value. So first sample, from sample we calculate means, from means we get a z-value, z-score, and using with the help of z-score we will calculate a p-value. This p-value is the final value that we are going to consider in our final assumption. If the p-value is more than the accepted range, then we will consider it. Otherwise, we will not consider it. Z-score is the actual. Z-score will give a normal number or something like this. So Z-score is the actual and p-value is the condition. So p-value is, okay, what is p-value? P-value is a probability value. That means percent of randomness in your analysis or percentage of randomness or error in your analysis. That is what a p-value is all about. So p-value means if I'm saying so first, before starting any model, I have to choose certain things like, the confidence level. Let's say I have assumed 95% is my confidence level. In that case, my p-value will be 5%, which means the p-value is 0.05, which means the p-value is 0.05. Now, while calculating all of that, if I get a p-value of 0.22, which is more than this, understand this very clearly. P-value means how much of error I want to have in my data. Confidence is how much confidence I will have in my data. I can only talk about it from p-value. So if from my findings, if I'm getting a p-value of 0.22, that means this is more than this. So 22 means how much? 22% is my errors. Then how much is my confidence level? My confidence level is 78%, but that is not right because I want my confidence to be 95%. That means for 90, if I do this operation for 100 times, for 95 times, I should get the correct result. For 5 times, I'm okay with getting errors in it. But this is not the case. In that case, I have to reject this alternate hypothesis. In that case, based on all the data I have considered, based on all the z-test I have done, all the samples I have collected, I will conclude that my, p-value is more than the accepted p-value. That means I am getting more errors in my data. I thought I will get 5%, I'm getting 22%, which is huge. So I have no other option but to reject the alternate hypothesis. And rejecting an alternate hypothesis means what? I'm going back to the null hypothesis. So I have to accept this fact. There's no other way. But in statistics, people don't say I accept the null. People say I reject the null hypothesis, alternate hypothesis. So the alternate which I was proposing, there is something wrong in it. And so I have to reject it. There's no way. I don't have statistically evident proof to support my claim. In statistics, it's all about claims, right? In statistics, that's what the definition also says. Where was it? There was a definition, right? Somewhere here. So, yeah. So whether a finding or association is statistically significant or not. So I have to say, like, no, my results are not statistically significant. So I have to reject the null hypothesis. Are we clear until this part? Sian, are we clear? Okay. Okay. So that is what about statistics, basics of it, how to derive, how to establish your hypothesis, how to do a test, and how to take a conclusion. Now, all these things are done in Python in a couple of lines of codes, right? If I do this in Python, it will be just 1 or 2 lines of code, but you should know these things. What is p-value? How much p-value we should take? How much confidence we should take? How to select the distribution. We have seen here is just 4 lines, and histogram will give you the distribution. But in Excel, we just show how the actual distribution works. What are the things we should calculate? What is the standard deviation, mean, and all of that. So yeah, that's about it. Let's have a stop today, and we will continue again from this tomorrow. Central limit theorem is something I will explain. These all are theoretical things, good for interview questions. Okay.
Yeah.
All right then. Thank you so much. We'll connect tomorrow.